Namaskar. Now, once we understand what is the meaning of scalar and vector, now we will have to give some focus on the vector physical quantity, because the scalar physical quantity can be described only by means of the magnitude. It is okay, fine. For the vector, along with the magnitude, there is a need of direction too. But how we can describe the direction? And normally we can say that if I say that towards right, if I say that towards front direction, then it is the observer specific. Okay, that means if we are standing in front of each other, then my right will be your left and your front will be my back side, etc. Means we will have to fix some reference standard for the direction. Actually, same thing is there for the magnitude also, and you have gone through that. We will have to fix some reference standard, and that is known as a unit. In case of the magnitude also, when I say that it is 2 kilogram, first of all we will have to define what is the meaning of kilogram, but that we have already done. And therefore the magnitude consists of the unit and the actual number. Therefore this is the number, it is multiplier. That means in 2 kg I will have to repeat a kg 2 times. Similarly, if I say that it is 1.5 meter, then already we have defined what is meaning of meter. That is known as a unit. This is unit. And what I will have to do? I will have to repeat the meter 1.5 times. Therefore 1.5 is the multiplier. It is purely a number. Similarly, in case of a vector, what we will have to do? We will have to have some standard reference. Now typically, if we will have to represent a vector, then there are different methods of representation of a vector. We will discuss what are the 3 different methods of representation of the vector. If I say that along this particular direction, then I can say that I will have to define that direction, that is a reference standard, and that is known as a unit vector. Say for example, I will represent this to be a unit vector r cap. Okay. Now it is a convention to represent a unit vector by means of cap on it and a small letter. Now what I will have to do? I will have to repeat this unit vector several times. This is one unit vector, again in the same direction, same unit vector, again same unit vector, same unit vector. Suppose I am repeating this r times, capital R times, then I can represent the entire vector as r bar. We are aware about that. The vector is represented by bar on it, and therefore r bar can be represented as r times r cap. Therefore r cap is the unit vector like the unit, correct, like the unit. Now why it is called as unit vector? Its length is unity. Typically it is the reference decided. For example, it is 1 kg and I will have to repeat it 2 times. It is 1 meter and I will have to repeat it for 1.5 times. Similarly, it is r cap and I will have to repeat it for r times to get the entire vector. Obviously, this r consists of the number, and that is magnitude of the vector, number and the actual unit. For example, if I will have to describe the force which we have discussed in previous example, it is 2 Newton along x-axis, then I will have to write it as, therefore I will write F bar is equal to 2 Newton along x cap. Here you will observe that this is 2 Newton is the magnitude, x cap is the direction, but the magnitude consists of the number, that is multiplier, and the unit. 1 Newton, we have defined what is the meaning of 1 Newton. I will have to repeat it 2 times. Along which direction? Along x-axis. And therefore a complete vector r bar can be represented as the magnitude and direction. This is one way to represent the vector. What is the second way? Now, okay, 1 minute. This is known as the magnitude direction representation of a vector. Magnitude and direction. R cap is the direction, along this direction. We can say that along this, and that is r cap. R times r cap will be r bar. The second way of representation of the vector is the graphical representation. Directly by pointing or drawing a graph, drawing an arrow, I can represent a vector. Therefore, I can say that this is the vector along this direction. And now in this case, the length will be proportional to the magnitude, okay, whereas the direction is same as the direction. Therefore, if I draw an arrow on paper, in 3 dimension it is difficult to draw this arrow, but on paper if I draw this arrow, then I can say that the length is this. Therefore, suppose there are 2 runners, this is runner A and this is runner B. Then I can say that runner A is running with this velocity, say for example, and this runner B is running with this velocity. Then immediately you can identify that the velocity or the speed of runner B is less than the speed of runner A, because the magnitude of velocity of A is more than the magnitude of velocity of B, that is arrow of B. Similarly, their directions are different. A is running along this direction, whereas B is running along the inclined direction. And for that we need the graph. That means we will have to draw a line, and therefore this is known as the geometrical representation, or this is known as the graphical representation of the vector. But again, it has some limitations. Here, suppose you are communicating with your friend on phone, then you cannot show that what will be the direction of vector, what is the magnitude, because he cannot realize that length of the vector is so and what is the direction of that vector. Generally, the local coordinate system, we will discuss later on what is the meaning of coordinate system, but suppose we are talking towards right, towards left, towards front, back, up and down. These are the references which we use. These are for the local. If we are in the classroom, then it is fine. A corner can be treated as the origin. We will discuss later on for the Cartesian coordinate system. And then I can say that in towards the student side, behind the teacher side, towards the right of student, left of student, up and down. But suppose we are on a ground, then it is difficult because there is no such reference. And in that case, we can say something about the east, west. Here also we have considered that the displacement is along east, it is along north, etc. But that is also possible. We can fix the reference standard for east, west, south, north, up and down. But these are the local coordinate systems. Local coordinates. It depends. One more scientific coordinate system is there, which is known as the Cartesian coordinate system. Sometimes you have gone through this Cartesian coordinate system. The Cartesian coordinate systems is the reference standard for fixing the direction. It consists of 3 mutually perpendicular axes. It is x-axis, this is y-axis, and this is z-axis. It is known as right-handed Cartesian coordinate system. Now, why right-handed Cartesian coordinate system? It is difficult to explain this through the video. In classroom itself, I will show you the right hand. This can be treated as a right hand. Okay, it is. The first finger of the right hand represents x-axis. The second finger of the right hand represents y-axis. And the stretched thumb, which is perpendicular to both first finger and second finger, represents z-axis, and that is known as a right-handed Cartesian coordinate system. Similarly, there is a left-handed Cartesian coordinate system too, but that we will discuss in the classroom. Okay. Now, if the vector is resolved into its component form, for example, if I say that I will have to go to a particular point in plane Cartesian coordinate system, therefore, if there are only 2 axes, x and y axis, what I will have to do? I will have to travel up to this, correct? But instead of traveling directly towards that particular point, if I travel certain distance along x-axis and then certain distance along y-axis, then I have reached this expected point. And this is known as the resolution of the vector into its component. What is the effect along x-axis, along y-axis, and similarly if I give the effect along z-axis too, then that is known as the vector resolution. Now I will give you one example. Suppose this is the vector a bar, correct? This is the vector a bar. Now this is a geometrical representation of a vector. Directly I am drawing the vector on paper. A bar can be written as a into a cap, where a is its magnitude and a cap is the unit vector along its direction. Therefore this can be treated as a cap. These are 2 representations, but one more representation which is quite important and it is widely used in physics, is the component representation. What I will have to do, I will have to draw a perpendicular from end of this vector a bar on xy plane. Therefore, I will have to draw a vertical line. The perpendicular on xy plane will be parallel to z axis. Therefore, I will have to draw a line on xy plane there. This is. Now, this can be treated as the component of A in xy plane. This is component, that is like a shadow, correct? Suppose the sun is exactly at the top along the zenith z axis, then this will be the shadow of a bar in xy plane. Now if I draw a perpendicular from this point on y axis, that will be parallel to x axis. Therefore, if I draw a line something like this. Similarly, if I draw a line from this point perpendicular to x axis, then it will be parallel to y axis. And similarly, if I draw a line parallel to this shadow towards z axis, this will be the perpendicular to z axis. Therefore, here it is perpendicular. As it is the three-dimensional figure on two dimension on a plain paper, it will be a bit complicated to understand, maybe complicated to understand, but see, these are perpendicular to x axis, y axis and z axis. Then I can say that this can be treated as the component of A along x axis and represented by AX. Means directly if I draw the perpendicular from end, from the head of the arrow, head of the vector on x axis, this is the arrow, it is a perpendicular. If I draw the perpendicular from A on y, this can be treated as a perpendicular. See, if I draw something like this, this is also perpendicular to y axis, it is perpendicular. Then this is known as the component of A bar along y axis, it is AY. And this is the component of A bar along z axis and it is AZ. Then the vector A bar is represented as AX along x axis. The unit vector along x axis is I cap plus AY along y axis. The unit vector, it is convention to write the unit vector along y axis to be j cap and the z component is AZ along z cap, where the unit vector is k cap. And therefore, this is one more representation of a vector. Later we will use this, we will draw this diagram again and again. And this is known as the component representation of a vector in Cartesian coordinate system. Now there are two more coordinate systems, later we will discuss. One is the polar coordinate system and other is the cylindrical coordinate system, where the components are different, but we will discuss that at that time. And now we can summarize that this is the these are the three ways of representation of the vector. The vector can be represented by the magnitude and direction. The magnitude consists of a number and unit, correct? Then the vector can be represented by the graphics, that is the geometrical representation of a vector by drawing actual arrow. And this is one more way of representation of vector, which is known as the component representation of the vector. Thank you.